Hello guys and welcome in this new lecture, and today we're talking about relays. Relays plays a huge role in the industrial automation panels because all the control systems are used to be using relays. Now in these modern days we use PLCs, DCSs to create algorithms and to control the different equipments that are in the factory or in the machine. However, relays are still used and they have their own application within our panel. So, at least for nowadays designs, relays are used as a buffer in between the actual actuator and the PLC. So, to protect the PLC from different hazards that may be caused from the equipment in the machinery, we use relays as a buffer and a protection layer. Or a really useful application is when we have a side of the electrical panel that is specified for button control and switches controls. See, not all the time you want to use the PLC. Sometimes if the PLC is down, you still need to control your equipment. So there is a part in the electrical panels that is sometimes designed, which is called MCC, that fulfills this job, using relays to do this control operation. Now, relays are mechanical parts that are operating on the principles of electromagnetic. Now, the purpose of relay is to control an equipment. It consists of two parts. The first part, as we can see, is a coil wrapped around a metallic part. Now, the second part and the first part are isolated from each other. The second part only contains contacts. It has three terminals, which are labeled NO, meaning normally open, NC, meaning normally closed, and COM, meaning common. So let's take this scenario. On the A1 and A2 coil terminals, there is no voltage applied yet. The moment we apply a voltage on A1 and A2 terminals, an electromagnetic field is going to be generated around this coil, causing that contact to switch between one terminal to the other due to the magnetization effect. So with this small signal applied on the coil, we can control a large device with large power consumption without affecting the driver because there are two isolated circuits. Now let's take a real example. Assume that we have a controller that is controlling this coil. It is energizing this coil when it wants the load to be connected and de-energizing it when the load should be disconnected. And the purpose of this circuit is that the controller will turn on the coil, which in turn is going to make the other side of the relay get connected and make the device power up. Now on the other side of the circuit, we have a device that is operating on 24 volt DC. Now let's follow this circuit from the positive terminal of the power supply. The positive terminal was given to the COM, and if we follow the COM, we will see that it's connected to the NC portion of the relay. And the NC portion is floating and not connected to anything. Now the NO portion is also free on the first side, and on the second side it's connected to a device which is rated at 24 volt DC, and this device is connected to the negative terminal of the power supply. Now as you can see, the device is only connected to the negative terminal. Now if we short circuit from the positive terminal to the NO, we're going to get a full circuit, right? So if we have any device, we just connect to the positive to it and the negative, and it will operate if it's a DC load. What's missing here is the positive terminal, and that's the role of the relay here. Now once we energize this coil from the controller, the COM will be connected to the NO instead of the NC. And the circuit around the device we have will be complete and the device will start operating. If we disconnect the coil, then the device will also disconnect here. However, if the device is connected to the NC, well, without energizing the coil, the device will be operating. And once we energize the coil, the device will be not operating. So connecting the load to NC will reverse this operation. Now, there is another type for these relays, which are the timers relays. Timer relays are operating on this principle. You energize the coil, and after some time, the load will be connected. This amount of time is adjustable beforehand. The way it delays the output is using electronics which are designed within this relay. So we adjust the time that the relay is going to take till it latches the output. Then we energize the coil, and after this time is elapsed, the contact is going to latch. Now there's a few types of relays, and they all depend on the rating. So you can have an AC coil and a DC contact, or an AC coil and an AC contact, or DC coil AC contact, or DC coil DC contact. So no matter what the configuration you have in your control circuit, there is always a relay that can control and can fulfill your needs. And please note here that when we are mentioning 220 volts, it could be 110 volts AC. So it depends on the country you're living in.